Alright, so in this video we're talking about factoring by using a method called the difference of two squares. Now, you probably have done this before in a previous class, so if you need to skip this video, that's fine. I'm going to go ahead and go through it just as a quick review for you. So, difference of two squares, I call it dots, difference of two squares. It looks like this. So, a squared minus b squared is what you're going to start with as your polynomial. Difference for minus of two squares. And it always is going to factor into this, a minus b, a plus b. Okay? So if you remember that pattern, difference of two squares is probably the easiest factoring rule you're ever going to know. So what I need to do is first, dots, difference of two squares. I have a minus in the middle, that's good. I have two pieces. Now what I need to do is try to come up with nice, easy square roots. So I want to say a squared, based on this pattern, is going to be 16x squared. Using this example right here, and b squared is going to be 100. The minus is not part of that. It's just b squared is 100. To get a and b, I need to square root. So I'm going to square root both sides. Because square and square root undo each other. Well, square and square root undo each other, so that means a is going to be equal to, alright, square root of 16 is 4. And then square and square root undo each other, so 4x. So everywhere I see an a now in my pattern, I'm going to put in a 4x. Same thing. Square root both sides, square and square root undo each other. So I have b, and then square root of 100 is 10. So everywhere I see a b now, I'm going to plug in my pattern and put in a 10. So that means 16x squared minus 100 it can be factored into 4x minus 10 and 4x plus 10. Just like we've done in previous videos, if you're not sure, you're kind of just have extra time and you want to check yourself, that's fine. Foil the box, whatever you choose. And I'm pretty confident that this is going to work out if you go back and check yourself. That was pretty easy. Again, this was just a review, so now what we need to do is step it up a little bit, okay? So, we're going to use the exact same difference of two squares, this pattern right here, but we're going to apply it to a more challenging polynomial. Alright, so in this example I have y plus 5 quantity squared minus 121. Okay, well I have two pieces and minus in the middle. So the very first thing that pops in my mind and should pop in your mind is dots, difference of two squares. So a minus b, a plus b, and that's equal to my a squared minus b squared. Okay, but I've got y plus 5. That's kind of complicated. So instead, what I want to do is, again, like we did in the previous videos when we were talking about bottoms up, we're going to use that substitution method. So instead of y plus 5, I'm just going to call that any variable I want. Why not x? So everywhere I see a y plus 5, I'm going to replace it with an x, and that's perfectly legal. So what I have now, rewriting my problem, x squared minus 121. That looks a lot easier. So based on our pattern, a squared is equal to x squared and b squared is equal to 121. Again, the minus is not part of it, so don't put negative 121. That's completely horrible. Don't do that. So now what we want to do is to find a and b, we're just going to get rid of the squares by square rooting each side. Square and square root cancel out, so I know that a equals x. So everywhere I see an a, I'm going to put in an x. Same thing, square and square root cancel out, so square root each side. So I know that b equals the square root of 121, which is 11. So in my pattern now, for this particular problem, I end up with x minus 11 and an x plus 11. But my problem had y plus 5. So you can't leave it like this. You always want to have your final answer the same way as your problem was given to you. So we started with y plus 5. We need to finish with y plus 5. So we're going to go back to our substitution rule that we made up at the beginning. Everywhere I see an x, I'm going to replace it with y plus 5. So everywhere I see an x, I'm going to replace it with y plus 5. Okay, and now I'm just going to clean up a little bit. So I end up with y plus 5 minus 11, so that's just y minus 6. And then y plus 5 plus 11 is 16. And that's it. Difference of two squares. Looks a little bit more complicated, but really it's just a new twist on an old classic.